Hi guys, welcome to Learn Electronics Repair. I have a power supply here, so this 1000 watt ATX power supply, EVGA. This I actually found at the car boot sale, the flea market, a couple of weeks ago now, and I paid the guy €10. Somebody else had one exactly the same on another stand and he wanted 15, and I said no. And I said, I'd give you 10, and anyway, somebody else had one, and I gave this one 10. The week after, the other one wasn't there anymore, so I thought maybe I can get that one as well. But anyway, it didn't cost me a lot of money. I don't know what condition it is in, so I thought, well, let's have a look. What I do know is that I have all these various cables with it, so it looks like all the cables are here. Even the power leaders with it, yeah. And there is some corrosion in this, so this has obviously been somewhere, well, anywhere on this island really, but somewhere near to the sea. Okay, so it has some corrosion. It has a little sticker here in which actually says August 20th or August 20, so I don't know if it's like 2020 or if it's just August 20th or for some other reason we have that. Okay, so let's have a look at it. And as I said, quite a lot of corrosion on this, which is interesting we get this because it doesn't rain here basically. Okay, very warm and sunny pretty much all the time. This is a 999.6 watt power supply, which then becomes 1000 somehow, but you know what, I wouldn't argue about that slight difference. Yeah, okay. Looks like there is some corrosion inside that as well, or at least some dust. I'll connect this, look, doesn't look too clever, does it? I'll connect this to my current limiting light bulb and let's see what it does. Okay, so you see the light bulb. We also need to attach this, so this is my ATX power supply tester. This means the power supply will start automatically when I switch it on, if it's working. So let's see what it does. Well, it went bright and dim, then this came on. So it's going to power up or something's going to happen. I hear the click. And it's telling me I have 5 volt standby, everything else is low, and power good is 0. So that means the power good never came back from the power supply. I'd say it's on the grey wire, but obviously these are all black, so we don't have a grey wire, but whichever wire it is, the power good didn't come back. So what's happened with this is it's in standby. The standby 5 volts is up and running, but nothing else is running. The fan didn't run. Okay, takes a long time to switch off. Now it says nothing else is running as well. The power is off, honestly guys. Yep, eventually off it went. So we have standby only. This is modified. I modified this best part of 4 years ago, one of my very old videos. So if you buy these things, unless they've seen my modification and improved them all now, the tester is powered from the 12 volts. So if the 12 volts isn't there, it doesn't do anything. Even if standby is there or 3.3 and 5 is there, it doesn't do anything. So you think the power supply is dead. Okay, and I actually had this on a repair video and spent a long time trying to fix the power supply, which I thought wasn't powering up, and it was powering up, it's just the 12 volts didn't work. Okay, so I modified this, and now it will power up if any voltage is present, whether it's just the 5 volt standby, 3.3, 5, 12, whatever, any of those supply rails there, or even if there's 3.3 on the 5 volt standby, it will power up. Okay, if I remember, I will link that video showing you how to modify these. But now we better have a look at this power supply. This is mine. It didn't cost me a lot of money, so it's no big deal. If I can or can't repair it, it may need some parts. It's never been opened, I'll say that much. So nobody's been messing with this at least. Let's have a look inside it and see what's going on, or rather, what isn't going on. Well, I've just about got it open so we can see inside now. This is what I'm saying about the corrosion on this. Okay. Let's see if we can just take this off. Even this is really jammed on. It'll probably break, but that's not going to be an issue if we can fix the other problems with this. Yeah, so let's see. No, it's come off. Okay, I think we can see to some extent what's wrong with this then. There's another board up here at the front. That's for the connectors. Okay, can we fix this? This is a good question. Let's see if we can actually dismantle it. I've managed to get this apart so we can actually have a look at the condition of this now. This is the eco switch on off. Okay, very corroded metalwork. I mean, this you can probably clean up pretty well with a bit of WD-40 and some emery cloth, I would think, if you wanted to. So I don't think that's actually a lost cause. This piece you can't actually get off easily, so you can see the PCB is soldered to the back of these, but these are inserted first, so you can't take them back out. So what I've done is I've actually unsoldered the two wires which go from here to the actual power input. Okay, you can see them there. So I managed to unsolder them from this side. Okay, and here is the PCB. So this is clearly a mess. I think that's probably a good description. It's a mess. Looks like water's got into this at some point. That's the best way I can put it. I think, yeah, the corrosion down there. This board I think will have to come off to clean that up. Okay. How easily does this come off? Let's have a look. So you could get that off. It would take a bit of effort, but you could. Okay. More at this end really. But I think, let's see. I'm inclined to unsolder this board. And if I can do that, then I think it looks like there's a plug here in actual fact. Yeah, that looks like a plug. If I can get this off, then I can more easily get into here. And I'm going to put the whole thing in the sink with hand wash and water, and let's see how it looks after that. So first of all, let's see if we can actually get this off. So to do this, I'm going to add some flux. I'm going to add leaded solder to all of these pins. That in itself should kind of burn off most of the flux because it tends to clog up the soldering tool. And after that, let's see if we can unsolder it. This is certainly not the sort of repair I would take on from a customer, unless this power supply was something special out of some expensive piece of equipment and it can't easily be replaced. Something industrial, then if I had to have a go, of course I would. Okay, but it wouldn't be an inexpensive repair. Having said that, I don't actually know what's wrong with it yet, so let's see how far we go. Is that unsoldering? I don't think it is. Oh, I think that one did. Let's see. I think with a bit of hot air, this might come off reasonably easily. Okay, so a bit of fresh solder. Warm it up. Okay. Yeah. Okay, let's see if I can actually get this off. Well, I've almost got it. It looks like just the two end pins are not properly unsoldered. Okay, so let's do those. Again, a combination of hot air and the vacuum tool should do the job. And I've just spotted there's another mounting point on this as well. So this one we need to get. Yeah, other end. Okay. And then there's something else which holds it in, I think, right at the very end. No, I don't know. Let's see. Yeah. I think maybe something here. Okay, let's see if we can just waggle this out. No. Yeah, it looks like there was a pin bent over, that's what it was. Again, still that one at the end, just soldered. Let's try again. This one. Nope. There's always one, isn't there, guys? Okay. Huh, would you believe it? We'll persuade it. Well, I eventually got it. I mean, you can see this is coming off quite cleanly now. But unfortunately, that last attempt with a lot of hot air took the pad off at the end there, which is not a good thing. I mean, we should be able to repair that. We have the pin sticking through here, so that's fair enough. Just figure out where it goes to. This is actually not part of it at all. So we have that. A bit unfortunate, but not a disaster that. It was just so hard to do that end one. For some reason. See if we can get the glue off this and then unplug it. This is still very warm, by the way. Now we have this off, we can see much better. Now this is the one that gave all the trouble, this pin at the end. If we look, it doesn't actually connect to anything. It probably does, but we see. Looks, yeah, it does connect to something. Okay, so this is the mess on here. We have this chip, WT7527. Could be some sort of buck converter. There's some coils here. We can look that one up. And this looks a lot better down here now. We can see at least what's going on. So this is the data sheet for the WT7527. We can see this is a power supply supervisor, so it's protection circuits, power good. Okay, so the power good comes from here, which is probably a good reason why this thing wasn't starting. Over voltage detector for the various voltage rails, under voltage for the same, over current monitor for the various rails again. Okay, that's what we have. Yeah, on off switch input, for example. So This is involved with the startup of the main supply, and I think we have a good reason why that isn't happening with this one. So guys, this is the result of sticking the thing in the sink. And we have some real corrosion problems on this one. So it didn't actually remove a lot of the corrosion, it removed a lot of the dirt. Some of this doesn't look very nice at all. Okay. I'll try a bit of ISO, but I don't think that's going to make a lot of difference. Let's see. We can say it's a bit cleaner. Doesn't look any particularly better. So this is where the solder mask has come off, and we can actually see the bare copper track there. Going off under this way, okay. Another one. It seems to have got rid of the worst of the gunk between the pins of the chip, at least. Yeah, so it did help, I'll give it that. This PCB then basically controls the startup of the power supply. We know we have 5V standby running, so that must be powering this board. But we can see here straight away we have a hole in the chip. There, okay, got a hole in it. A bit hard even to read the marking of that one. Okay. Something 231. Looking for another similar chip to that. It might have the same markings, but no. So that's the first issue. I say first issue, there's plenty of issues already, okay? The problem with this sort of failure is this is indicative that a lot of energy is being dissipated somewhere. Yeah, which that means current is gone somewhere, and anything in its path could be destroyed, basically, or damaged, okay? And this is just the low voltage, this is a startup board. That fits into here, so you can see this is where I had the problem desoldering this one. On this side of the board the pad came off, but that's because it doesn't connect to anything. You can see a gap between here and here. This is just a gap. There's no connections to that pad. But what I can say, and this is all pretty much academic guys, I'm sure you realise that, but I can say from here we have a diode, it looks like a diode, or a Schottky diode to ground. No, actually we have a capacitor charging. So it doesn't go to ground, yeah, there it cuts out, you see. So it doesn't go to ground, it goes to some sort of power rail, and the capacitor is there, so it is charging. I suspect it probably goes to 5V standby, that's just a guess. But I'm sure if I solder this back in, that would connect. The problem is, A, I don't know what that is. And then there is the issue with this pin. So you saw in the video, I had this desoldered. This leg was waggling around the same as the rest. So it's not a case that this pin got ripped out, or rather this via, when I removed the board. It had come loose while it was still in the board, and it just came out, okay? That's possibly related to the corrosion in this area as well. So this possibly goes to here, actually. Let's have a look. maybe not to there. But I think what we can say is we have some metal here, okay, and the other side we have metal, and that one clearly goes off down a track in this direction. So if I solder this in, let's just look how, if I put it against here, yeah, look. You can see that that wire went all the way through the board, okay. I doubt it was attached to an internal layer just because it came loose, if you see what I mean. I mean, obviously, could be wrong, but I think if we insert that and make sure I can solder from both sides, so that means getting a bit of soldering from the top, or otherwise put a thin bit of wire through the hole first, solder either side but leave enough space for the pin, if it will fit. Yeah. And then we're good. I think, in all honesty, I'd probably be tempted to solder this in just slightly, not quite flush, you see what I mean? Sort of like that, and I can probably get down there. But either way round, that's not going to be a problem, I don't think. And the other problem is the other corrosion. So all this area, this is basically low voltage. This is the low voltage side of the power supply, okay? So this is all low voltage. Looks like we have, these are all diodes, this is all the rectifiers, we have capacitors on the outputs. You can see this is the secondary, this is the standby supply, okay? And then the main power supply is driven from here, so PFC and main output. And then this is the mains in, so this part of the PCB is clearly isolated from that part of the PCB. So the mains comes in this way, okay, through some low value resistance, parallel, probably current sense. That's the bridge rectifier we can see there. This will be the PFC inductor, I would say, and that itself has a bit of corrosion in it. These are the two large capacitors. So down here you'd expect to find the PFC diode and MOSFET. I can see 3 devices, maybe 4. That has 2 pins. There's 1, 2, 3 bolted on. Okay, 3 pins, 3 pins, 3 pins. So there's 3 devices on there. So on the other side, yeah, something down there as well. 4 devices. Just looking to see where that other one goes. I don't easily see the legs of it. Okay, we can make a couple of checks with this. I mean, this would possibly be repairable if you really needed to or had a good reason to. All the high voltage side of the circuit looks okay from a corrosion point of view. Yeah, I'm just looking for shorts around here actually, to be quite honest. Nothing short there. That was a little blip, maybe I caught something. Nothing short there. Oh, those connect to each other. Okay, I think that's the heatsink tab actually. So no shorts around here. These are the current sense resistors, so they read okay. So you'd assume that if something had gone bang, they would probably go open. There's a fuse here, mains fuse coming in, 15 amp. That reads okay, but I'm a bit concerned about, again, corrosion around here. Around here. Okay. It would be easy enough to test if the path is there. All we would need to do is just to measure from the fuse, or live and neutral even, which is where they come in here, to either side of the bridge rectifier. I would soon know if we actually have good tracks there. I mean, that's easy enough to do. This is where power comes in. No short, but I think we already know that. These are the bridge rectifier. There's either two of them in parallel, or it's like a kind of a very interesting device. I think it's two in parallel actually. Okay, so middle two should go to power coming in. And that's one side. That's the other side. So that's all okay tracks wise. We won't see a connection from here to the two large capacitors because there's PFC in between. And on this one, the two large capacitors are in parallel. You can see here to here. So we should see these charge up. In fact, he's discharging in one direction. That is suspicious. But I'm measuring, this is the negative end, so the direction in which this charges is actually that way. And that looks fine. So you don't really have to worry about that other direction. I mean, it doesn't mean anything to real use. Okay. And then we have your main switching transistors, which are on this heatsink. I'm pretty sure that's where they will be. The transformers here. Again, we can have a quick look around the heatsink, which is in this area. Looks like a switching transistor. Again, capacitors charging or discharging. Yeah, going open. So certainly not a short. There's that one. Are there any more? Yeah. Down here. Some more switching devices. 1, 2. 3 at least. Well, I think I can see at least 2 of them here. So have a quick look. Just go the other way. Yeah, let the capacitors charge. Okay. Again, don't see any shorts. Just the thing with capacitors. Probably reverse direction. This is probably the collector or drain. That might be the PFC diode. These, yeah, like a diode 0.466 fast switching diode. I think that because this end seems to connect directly to the electrolytics. Yeah, I'm sure that's a PFC diode. Okay, so I would say that this chip here controls the switching transistors and the PFC, so some sort of combined PFC and switching. I looked up this port 6600, can't find a data sheet. There's a bit more rust around this area, but it doesn't seem to be part of the circuit as such. Yeah, this relay will just short out the thermistor, and the thermistor isn't blown. So there's a lot of indications here that I haven't had any sort of power surge in the high voltage side of the circuit. All the problem seems to be in this area where some water or something's got into it, and that's basically on here where we see the blown chip. A few more diodes on here. Let's have a quick look. That reads like a diode. This meter blips continuously unless you switch it off on diode, by the way. Looks like a Schottky. Reads probably a bit like a Zener diode. That would get Z. That'll be a Zener diode. We have a few more SMD devices on here. So I think if we could identify that chip, that reads like a Schottky. If we could identify this chip, it may even actually fix this thing. The question, of course, is how reliable would it be if I did? But I think, out of interest, if anybody knows what that thing is, let's just get under the microscope. That one. Is that voltage regulator? 78M. Something of the Texas Instruments. 78M. Makes me think voltage regulator, 78 series, but there's no adjustable. Is that right? Maybe this is 78M AJ, which is like an adjustable variable version of a linear 1 amp or something chip. Let's look this number up, 78M AJ N2. Well, people have looked for it. Whether they found it or not, I don't know. Nothing specifically coming up there. Try that. Let's put the TI for Texas Instruments as well. 7.8 fixed voltage regulators. Well, I don't really find a datasheet for that thing, but it looks like it might be something like that. Yeah. If it was, there would probably be some close tolerance resistors around here, and we do have. So this 15C and 49C, you'd have to look the codes up, but those would be 1% tolerance resistors. I suspect that is a voltage regulator. If we could find a datasheet for that and figure out what it powers, maybe we can figure out why it went bang. So yeah, this one's a kind of, I think I could fix it with the information. How reliable it would be if I did fix it is questionable. I have no datasheet for the controller on the high voltage side, so if this doesn't fix that problem, well, I probably couldn't do anything else. What are these things? Look a bit swollen, but I'm not sure. HD1, HD2. These things. Whatever it is, it reads open in that direction. 2.64, that's in diode mode in that direction. Diode. Okay, so they really like diodes. They look like they're connected into this area as well. Okay, guys. Final thoughts. What's that? Yeah. Do you think I could fix this? Do you think it's worth doing? Down there, let me know. Okay. Did you enjoy just looking around the disaster we have on the bench? Hopefully. And I look forward to seeing you all soon again on Learning Electronics Repair. Ciao for now, guys.